Okay, I think we'll get the talk started here. Thanks for dropping by. I know it's the last day of PDC, and probably some of you were running around last night, but hopefully you'll find the talk well worth it. I'm going to be going over basically two general things today. One is what the plans are for cache extensibility in ASP.NET 4.0 itself, and also more generally what we're doing to add cache extensibility for non-web applications in the .NET framework. So very briefly, I'm just going to go over the current state of what we've got in caching, just to sort of level set the discussion. And then I'll drill into why are we thinking about making the changes that I'll be discussing here in 4.0, and then more specifically drilling into the current state of the designs that we have. And I'll tell you up front that basically a lot of this is sort of very early days. Literally, some of the stuff we're doing in output caching is probably no more than a month old. And the work we've been doing on the object cache extensibility is literally still in design phase. So you're definitely sort of seeing it as those of us in the product group are working on it. Okay, so where are we today? Where are we in the 2.0, 3.0, 3.5 framework? There's obviously a built-in in-memory cache. It lives inside of ASP.NET. It has a lot of functionality that folks have gotten accustomed to using over time. So as we like to say it, there are lots of knobs that you can wag for controlling how things get put into the cache, how they get expired, whether or not you have time-based expirations or using business logic to expire stuff. And then in addition to the object cache, there's the output cache. And output caching is, of course, very specific to ASP.NET. There's not really any concept of output caching for obvious reasons in a WinForms or a service app or a WPF app. And basically, output caching in ASP.NET is built on top of the object cache, and its purpose in life is to let you, do full page caching or fragment caching of just individual controls on the page. So this is all stuff that we've had to, one degree or another for quite a few years. So why are we going to come along here in ASP.NET 4.0 and in the 4.0 framework and suddenly start mucking around with it and making changes? And basically, I've got up here the two biggest reasons why. First one is that just the object caching that we have, the in-memory cache, even though you can use it today outside of ASP.NET, and we do actually support, it's a fully supported scenario to go use system web caching cache inside of your WinForms app, it's a bit of an oddball relationship because you're sitting there in the middle of a project that has nothing to do with the web and nothing to do with ASP.NET, and all of a sudden you're referencing system web DLL. And again, technically, it's not breaking anything, but it is a bit of an odd thing to be seeing that in the middle of your project. And then even more importantly for us recently, earlier this year, we released the SP1 version of the 3.5 framework, and one of the important things that we did in 3.5 SP1 was that we factored out the framework, and we actually have a stripped down version of it called the client SKU. And that's meant to make it easier for click once scenarios where you run a WPF app or a WinForms app on the internet. It's meant to make it much easier to pull down the framework. Well, this is a perfect example where, something, for obvious reasons, we didn't put system web DLL in the client SKU because, my mom who's going to run a tax app does not expect to be slurping down ASP.NET from the web. So that's a perfect example where even though the object cache today in 3.5 can be used outside of ASP.NET, we're now at a point where we're coming up with different SKUs and different packaging versions for the .NET framework where just technically we can't bring those bits along. And so we want to be able to address that. The second biggie, and this is probably the one that we've gotten lots and lots of feedback from vendors, developers, you name it over the years, is that the caching that we have in the framework, whether it be the output cache or the object cache, it's a black box. It's like we have a bunch of APIs for object caching. We have a way that you interact with the output cache in ASP.NET. But if you want to go out and write your own cache with your own semantics, if you want to go out and use things like memcache or scale out, folks like that, you basically have to run off and you use some different library, and it's a completely different programming model. And again, it's fine to do that. It's just there's not really any clean integration point. And of course, the downside is your developers end up having to sort of relearn how to do the same basic tasks over and over again each time they decide to use a different caching strategy. So again, that's one of the things that we're going to try to address and solve here in 4.0. Okay, so on this slide, I've got the list of sort of the general things that we're going to be doing. First off, for object caching, we're going to come up with a new namespace, and you'll see the preview of it in a few minutes, and a new set of API surface area that's all going to go out and live in a separate, brand new assembly that becomes part of the 4.0 framework. And for those of you who've been using the existing object cache, it's not going to be, a huge change. There's still a cache, you still add things, you still remove them. I mean, at the end of the day, it should all be pretty familiar. But again, the API is going to look a little bit different because it's factored out, it's going to have pluggability in it, and there are a few new concepts that we're adding to it. And then what we're planning to do is, along with the new APIs and the new assembly, is we'll give you sort of a default implementation of an in-memory cache. And internally, we've been sort of going back and forth. A couple of different teams, other than our own, have had ideas on like, well, okay, what would be this new in-memory cache engine? And right now, what it tentatively looks like, again, subject to change, but tentatively, it looks like we'll take the ASP.NET in-memory cache, we'll basically pull it out, clone it, and drop it into a new standalone assembly. So you get sort of the same behavior, but you won't have to drag System Web DLL into the mix. And of course, the other nice thing is because we're doing all of this in a brand new DLL that's separate and off to the side, when we start worrying about how to build the client SKU for the 4.0 framework, we'll actually be able to include caching in it. And then another thing that's also on our plate, I don't know if some of you folks use it, but the CLR support in SQL Server, they've actually asked our team multiple times, could you make System Web DLL and do a bunch of low-level engineering changes to make it usable inside of SQL Server? And apparently the number one reason we get asked that is because people want to use our cache, for whatever reason, from inside of SQL Server. So again, that's another scenario where all of this refactoring and engineering work will actually make that possible. And then for output caching, which also I'll talk about today, there the changes are, I'd say, they're much less radical, right? Output caching is still there in ASP.NET 4.0. It's still got the output cache directive. It's got the programmatic APIs. None of that is being sort of reinterpreted or rejiggered. Basically, what we're doing is we're just sort of hoisting everything up and slotting a provider layer in underneath the hood so that if you want to, you can throw out our basically in-memory backing store, and you can slot in your own output cache provider that runs against a disk or runs against the cloud or whatever it is that makes sense for you. So what I'm going to do now is just first off sort of step you through at a high level of what the new API looks like, and then we'll switch over in a few minutes onto the laptop, and again I'll walk you through the basics of what we've been working on. So the current working proposal, and again subject to change, but this is sort of where we're at as I stand here talking today, is we'll have a new namespace, system.caching. Makes sense. You want to get to a cache, go to the system caching namespace. And you'll start out with an entry point object, which right now I've got up here on the slide is being called cache. Ironically, we will probably end up having to change its name for the simple reason that if you are in ASP.NET and you're using the cache object today, and then you want to move up to the new 4.0 object caching, if we don't actually come up with a different name than cache, you'll end up with the old problem of ambiguous type reference. It'll be like, did you mean the ASP.NET cache or did you mean the new 4.0 object cache? So I'll say tongue-in-cheek, if any of you have a marketing bent, we'll pay you $5 million to come up with a new name for the cache object. But seriously, if you have any ideas, it's like, let me know, because we need to call it something other than cache. But for now, we've got the entry point object. And the idea is that we also have that object sitting on top of a pluggable layer. And so you have a cache provider base type. There's actually some specializations of this type that I'll talk about a little bit later in the talk. But the general idea is, in a piece of code, you say, I want to go out and use a cache. And by the way, I want to use provider XYZ. And then you're off to the races, and you start programming against the cache. And as the slide implies, you can have one cache provider, you can have 15 cache providers in your application. You can go out and have disk-backed caches, in-memory caches, distributed caches. You can have all of them configured and running in your application, and you can mix and match whichever ones you want to be using at runtime. And then the providers themselves, like I said, what we're planning to ship at some point in time, probably later, closer to 4.0 RTM, is a default in-memory cache provider implementation. We have kicking around just internally right now a prototype, and you'll see it in a bit on my laptop, of a disk-based object cache provider. If there's enough interest in it, sometime after 4.0, we can actually drive that to sort of RTM grade and get it out the door. You've probably been at least a few talks about our cloud computing strategy. Our team works pretty closely with some of the folks over in Windows Azure. And so what we're planning to do is probably CodePlex would be the first approach sometime next year, an Azure-based cache provider, so that if you literally wanted to go out and cache stuff out in table storage or SQL Server data services, you'd be able to do that. And then again, just to be upfront, it's not that all this is going to show up as sort of RTM grade stuff in the 4.0 release, but the deal is once we CodePlex it, we can get all of your feedback. We can tweak these providers up, and then whenever the heck the next ship train comes through, whether it's for our framework or for the Azure SDK, we can pop it in there and make it available to everybody. And then lastly, I sort of have distributed here as just a separate concept. One of the biggies, one of the big things that we want to make sure works in 4.0 is both internally and externally, people who use distributed caches and who write them, we want to make sure that those folks are able to clip into our object cache and feel like, yes, I can actually make use of whatever it is that I'm gonna pick, whether it be Memcache, like I said, vendors like Scaleout, or whether it's the Velocity product that we have from the SQL Server team. Now, what happens is once you actually have this cache object and you start working with it, a little bit of a departure from what you may be familiar with in ASP.NET, with the cache object, you start working with cache items. And the reason for that is the second you move away from just a straightforward in-memory cache, you usually have more information about the stuff that's going into the cache. So obviously today in ASP.NET, it's just, hey, I got a key, I got a value, the end. But the second you look at distributed caches, for example, they have different kinds of locking strategies, so you need some place to sort of hang optimistic or pessimistic lock handles off of a cache item. So that's why we have this cache item type. And then there's other metadata, like for example, Velocity has the concept of query tags. So you can actually say, yeah, go stick this item in the cache, but go associate it with this query tag called, product catalog. And so again, you need a way to sort of hang all of this data about the data somewhere, and that's what the cache item type represents. And then the other thing that cache item does is it also has references into the expiration policies associated with the value. And again, if you've worked with ASP.NET, this should be pretty familiar. You know that we have both sort of static expiration information, so that's things like, a sliding expiration or an absolute date expiration. And then you also have sort of more business logic-driven functionality, and those are things like SQL dependencies or custom cache dependencies. So all of those concepts carry over into the new Object Cache API. It's just they show up slightly differently in terms of the object model. Okay, so with that sort of brief background of what we're looking at, I'll switch over to my laptop. And what I've got up here is just sort of a custom internal build of the 4.0 framework. I've got VS 2010 up and running. And I've got a WinForms app, intentionally, not a web app. And I'll walk you through sort of a preview of, again, some of the simpler stuff that we've got running right now with the new Object Cache API. So first off, let's take a quick look at references. You'll notice in here there is no system web DLL. What there is, however, is a system caching DLL. So again, that's just sort of to reiterate the fact we want to make caching just sort of a generic service that's available for anybody in the framework as opposed to sort of artificially stuffing it into system web DLL. The other thing is if we drill into config and take a look at what I've gotten here, you'll notice that there's this new section here called system.caching. And again, subject to change, right? We might change names and sort of jiggle things around. But the general idea is, just like other features in the framework, there will be configuration where you can specifically say, yes, I am going to use the cache feature. And by the way, I have different caching engines. And by default, please go use, like in this case, the memory cache provider. Now, again, if you're coming from an ASP.NET background, you can pretty much guess, what's going on here underneath the hood. If you've used membership or roles, profile, or session state, you remember back in 2.0 days, we made all of those provider-based. It's the same idea here, is that at the very lowest level, we just took that exact same provider infrastructure and said, well, look, if you want to go write a caching engine, it's actually a provider, and you can go out and stuff as many of them as you want into config, and then basically the higher level cache feature can go out and interact with them. So with all that said, let's go out and just do some basic stuff. So first off, let's just see what coding looks like when I want to stick something into the cache. So this is sort of the first big difference, right? This line of code, I actually newed up the cache so that I could actually get something to work with to call, for example, adding an item into it. And if you work with ASP.NET, this may be a little bit of a departure, because you know in ASP.NET, if you're sort of in a page code behind, or even if you're in a handler or a module, on the HTTP context it just says, hey, the cache is just here. On the other hand, if you've ever worked with our caching stuff from a WinForms app or a WPF app, you always had to do this weird thing like you'd new up this HTTP runtime cache type and then start using it. And it was sort of oddball that you had these two different ways of getting into the feature. So in 4.0, the idea is we have basically a cache facade, which is this cache type. And anytime you want to start working with the cache, you just new up an instance of it, and you call whatever it is, you know, adding, removing, getting items, whatever it is for functionality on that object. And so similarly, if I want to turn around, and in this case, get an item out of the cache, I say, great, get me a reference to the cache, and please get me, in this case, the item with the key of 123. Now, again, this is early days, so right now we only have the comparatively ugly operation where you have to explicitly cast to the return value. But again, between now and RTM, at least on the getters, we'll probably end up, you know, having generic type T, so you can say get T of whatever out of the cache, so that you at least save yourself that. And then just because I know sometimes it can be a little bit hard to see what shows up in the debugger, we'll just pop that up in a message box. So okay, we've got the cache system. It's using the in-memory cache. We're going to insert an item. I'm going to turn around and get the item out of the cache. Again, you probably barely see it in the back there, but there we go. We've got the value. Foo value came back out of it. Now, on the other hand, let's go out for the heck of it, and let's go out and use a disk cache instead. So I'm going to come back here to my insert call, and instead of just saying new cache, I'm going to use one of the new overloads that takes the name of a provider. So I'm going to copy the name out of configuration. I'm going to pop it into the constructor. I'm going to go out and save that. And then again, we'll go out and rerun this project and see what happens. So I can go out and I can insert the item. Now, of course, on the other end, if I get the item from the cache, what happens? Nothing's showing up. Because the insert operation, I specifically said, please use the disk cache provider. But for the other call, I didn't actually tell it which provider specifically to use. So this style of coding says, please use the default provider. So okay, let's go out and let's make that minor change. Let's say, hey, you know, when you get that value, actually please do use the disk cache provider. Now I'll start the project again, and this time I'll say, please get the item from the cache. Now, notice what ended up happening here. I got this is in the disk cache. So I ended up stopping the application. All the memory went away. I started up the application again. I said, please get me a value out of the cache, and there was actually something there. Now, if you're following it really closely, you might notice, though, that, wait a second, this is in the disk. That isn't what the heck I typed into my project, right? What did I actually type into the project? I typed in foo value 12345. So what actually happened there is, right, previously when I was playing around with my stuff on my laptop, you know, I already had an item sitting inside of the cache. So instead, let's go out and actually I'll run the project again. In this case, if I do insert and a get, I'm still getting the old value out of the cache because the add method in ASP.NET, remember, it basically says, please put an item in only if it doesn't already exist. So let's go out and quickly rectify that. We'll say if c.contains, so if I already have a value with the key of 123, we'll go out and we'll explicitly remove that item from the cache. So we'll go out and save that, run it again, we'll go out and insert the item, and this time around I get out foo value 12345, which is what I expect. So this is something where, you know, with the extensibility, you can start plugging in different cache engines, but on the other hand, you have to realize that, like in this case, my little sample disk provider, you know, you may suddenly start getting slightly unexpected behavior because instead of the application going away and all the cache items, poof, they're gone. It's like, guess what? If you're using a disk-based provider or a distributed cache, the items are actually sitting out there for quite a long time. So, like I said, it's sort of a pretty cool feature that you can do that, but on the other hand, from a coding perspective, definitely if you've only been working within memory caches, you'll have to start thinking about, oh, wait a second, if my items are actually sitting around for a while somewhere else, you might have to have slightly different coding strategies to deal with that. So another thing I wanted to show here was, how we actually work with multiple items. And the reason why that's interesting is that when you're working with an in-memory cache, usually you don't care. You're like, well, do I care if I want to get 5 items or I want to get 50 items? I mean, who cares? Everything's in memory. It's all a reference. It's all very high speed. But the second you go out of proc, and whether that's going to the disk on the same machine or going across the network to something like velocity or scale out, suddenly you might not want to be sitting there constantly hammering away across the network every single time you get an item. So basically, I've got a little sample here that'll show first inserting a couple of items and then getting them back out. Now, the difference here is that in the new API, we do have support for getting multiple items, but currently, it'll probably show up here on this machine, but in the current bits we have internally, we don't have support for doing things like inserting or updating multiple items at a time. The only thing we support right now, or that we're planning to support, is the ability to get multiple items all at once. So I'll show you an example of what getting items looks like. So I'll say, something, I'd like to get a list of cache items out of the cache, and I'm going to say, please get me, in this case plural, get cache items, and I'll say, something, I'll need a string array because all of my keys are string values, and so get me the first item and get me the third item. And so this is one overload of what it looks like to get multiple items out of the cache. You'll notice that this overload actually makes use of the cache item type. And the reason for that is, again, for an in-memory cache, you may only have, a key and a value pair. But again, if you're in a distributed cache, there may be metadata like query tag information or a version signature that you also want to pull back. And so that's why we have this option to go out and say, okay, get me every single item that I asked for, but get it as an actual instance of this cache item. So we'll go out and we'll say, great, for each cache item that is in items, we'll go out and just pop up a message box showing the value. Now in this case, because I've got an instance of this cache item, I actually have to drill into it, and I have to say, get me some information out of it. And you can actually see here what I was talking about earlier. This cache item type has a bunch of different property information on it. So in my case, I actually want the item value. And in this case, because I actually inserted a custom type, in this case it was an instance of order, I'll have to go out and cast it. And again, I apologize. I know right now this is sort of the ugly way of doing it, but again, we'll sort of add generic support to this in the future. And what I'll do is I'll crack out the order ID, which I know is a string, and then I'll go pop that up. And then we'll see whether or not I actually got all my parentheses correct. So, okay, let's go out and see if we can work with multiple items. So there we go. I was able to get the first item, and I was able to get the third item, and I intentionally did not get the second item that I inserted into the cache. So that just gives you a quick flavor of a new piece of functionality that today doesn't exist inside of the ASP.NET Caching API, but we do have the concept of doing multiple get operations in the new object caching system. Okay, I'll switch back over to the deck, and we'll talk a little bit more about some design concepts. Okay, forward. There we go. Okay, so I was talking about object caching. Let's switch gears a bit and talk about output caching and how that actually looks in the 4.0 framework. So you know that today we've got system web caching as the namespace. We actually have some support in there for object caching, or excuse me, for output caching. You can go out and output cache entire pages, and then you can also go out and output cache individual controls. And like I said earlier, we haven't gone out and somehow torn apart the sort of upper level of that API or that feature set. Again, you still have output cache directives. You still use it in the exact same way. The big difference is that we slotted in an output cache provider layer underneath the output caching feature. And so again, what that gives us the flexibility to do is to go out and start using completely different backing stores for the ASP.NET output caching feature. Now, again, just talking about sort of time frame, ship vehicles, when will you see what? Right now, we're thinking that the extensibility mechanism for the output cache provider, you'll probably see that hopefully in one of the initial betas of the 4.0 framework. We internally use sort of a prototype disk-based output cache provider to validate the design, because obviously, in this case, like if we don't write the provider, we don't know if we got the extensibility point correct. So we do have that. Again, though, for the disk-based provider, the current plan is, like when the betas come out, we'll go out and codeplex our internal disk-based output cache provider. At this point, just time frame-wise, I doubt we're going to be able to include the disk-based output cache provider actually in the 4.0 bits. But what we will do is we'll update it right around the time 4.0 RTMs, and then this is one provider that basically, once we get some runtime on it, it will end up folding back into the framework in some subsequent release. And again, if you sort of work with output caching, if you remember back in like 2.0 days, for a few months there, we sort of had a preliminary disk-based caching solution, and that went away. And basically what we're trying to do here is make sure we get into the framework the extensibility mechanism and get that out the door, because then that gives my team the ability to sort of stress test and perf test a disk-based solution completely in parallel, but without having to worry about sort of shipping timelines. And then, as they say, we'll sell no wine until it's time. Well, basically, we won't ship the disk-based output cache as a fully supported item until we've actually been able to run it for a couple of months under stress and stuff. So with that said, let's go out and take a look at output caching running on my laptop. Alrighty, so I'll switch back to my laptop, and in this case, I'll switch over to an ASP.NET project. And much like you would sort of expect, as I was showing with the WinForms project, the first and sort of most obvious change that you see is inside of config, we again have sort of added some new functionality. In this case, all the way back since 2.0, this entire config hierarchy already existed. So there's already an output cache directive today in the framework. But what we've done is we've modified it so that once again, you have a place to specify one or more output cache provider implementations, and then as usual, again, you have a place to sort of specify what's the default. Now, what you're seeing here is a little bit of a mock-up. The reality is sort of this memcache thing for the output caching stuff that will probably end up being like an internal type that's basically the default of how output caching used to work. And you'll tell us, okay, go use the the in-memory caching, and you wouldn't actually, I don't think that when we actually ship this, I don't think you'll actually have to explicitly say, oh, by the way, there's a provider from ASP.NET that works in memory, because it'll be like, well, it's already there and it's available. But you can certainly rack up other provider implementations. So let's see, right now I've sort of got the output cache extensibility feature pointed at an in-memory cache. And come here, right now I'm on default ASPX. So great, I got my output cache tag. I've got something very basic here, the vary by param tag. So the first thing we'll do is we'll just say, hey, wait a second, did we go out and manage to break the feature just by putting in the extensibility? And it looks like so far so good. Like, okay, great, we didn't break the feature, so that's a good thing. So let's actually do something a little bit interesting. Let's switch it over to a disk cache provider. And what I'm going to do is just pull up the IIS MMC so that I can actually stop and restart app pools. Because obviously, if I were to stop the app pool now and then hit refresh, right, I lose everything that's sitting in the output cache. And I don't want to do that. I actually want my output cache data to stick around. So let's come back to web config, and let's say, something, I actually want to use the disk cache instead. So we'll go out and we'll save that, and we'll go out and we'll hit refresh, just get everything primed up. So, okay, we're looking at 10/43/47, so we'll keep that date in mind. And then we'll come in here, I'll come to my ASP.NET 4.0 app pool, I'll stop it, give it a few seconds to shut down, start it up again, come back to my application here, and I hit refresh, and you see that the same cached value still sticks. I've got it on a 60-second timer, and the actual cached value survived the worker process and the app domain restart. And in a nutshell, right, the big motivation for us to do the output cache provider extensibility is so that, again, we can write a disk output cache provider, and folks who have distributed caching solutions, again, the Velocity, Scale-outs, and Memcaches of the world, you can do the same thing and sort of get this persistence of values. Now right now, my sample there was using some pretty basic output caching. We can sort of mix it up a bit, so I'll go out and say, hey, let's go vary by param. You know, let's see, does that actually still work once I slot in the extensibility? So we'll go out and we'll say, okay, Q equals foo. So we'll get a foo version, and we'll get a bar version, and we'll get a baz version. So I got 3 different versions floating around in cache, or at least I hope I do. So you see I flip back to the foo version, I flip back to its cache date. If I go back to bar, it goes back to its version. If I go back to baz, it goes back to its version of the output cached image. So even though we've sort of slotted in this extensibility mechanism, it's not just something rudimentary of like, well, you know, here's the page and here's the cached value. We actually support almost all of the vary by options. So in this case, I'm varying by a query string. You can go out and, again, vary by controls, vary by form names. All of that stuff is still functional and available when you're using a customized output cache provider. I'll flip it back to none just for now. And then another thing I wanted to show that you can still do, even though I've got a disk-based provider running, is you can also still use features like donut caching. So I'm going to use response.write substitution. This is something that came out in 2.0. This is the programmatic aspect of it. You have used it with the declarative cache substitution control. But what it allows you to do is it allows you to go out and say, you know something, even though I'm output caching the entire page, there are actually little bits and pieces of it that I need to have change on a regular basis. And, you know, prior to 2.0, you had to sit there and carve the page apart into like 15 user controls and figure out, well, these 13 are cached and these 2 aren't. It's actually a lot simpler if instead you make use of this donut caching feature. So I'll go out and I'll register a callback for my donut caching. Hopefully I've got that written. And we'll come back to my page here, go out and hit refresh. Okay, and so now you can see what's happening. The data at the top, that's coming from the page level output caching. The data at the bottom, that's the cache substitution feature that's still being called every single time that the page is being run. And again, all of this is occurring against a disk-based output cache, not against the in-memory output cache. And sort of the reason why I wanted to show that to you is, you know, even though this is a disk-based cache, you know, we could have gone out and again slotted in something like velocity or memcache. An interesting point is once you're actually storing the data outside of the process space of ASP.NET, like how the heck are we actually getting to this callback, right? And what we did inside of ASP.NET, when you use an output cache provider, a custom one, we did add one restriction, and that restriction is this static definition right here. So the deal is if you happen to be using output caching today and you either use a validation callback or you use cache substitution, you might have been using it with an instance method on a type, and that works when you're running in memory because I can always get back to the instance. If you go to an extensible output cache provider, you can still use those features. The slight restriction is you need to use a static type. And the reason for that is internally what we do is, for example, like in the disk output cache, we actually write out the type definition and the method that we need to call on the callback. And that way, like for example, if we cycle the worker process, we can actually read that back off of disk and reconstitute the delegate, which is something that's basically impossible to do if you use an instance-based method. So okay, that's sort of page-level output caching. But there's one other point I wanted to go over, which is certainly when we were designing the feature, we were like, well, you know, great, I have to go into web config, and I picked a default provider, but, you know, what happens if really what I want to do is run everything in memory, but a few pages I'd actually like to use the disk output cache? Well, it turns out, and I'll flip to a different page that'll do this, it turns out for page-level output caching, when you use a custom provider, you can't actually specify the provider on the output cache tag. And it's sort of counterintuitive, right? You would think like the most logical thing is why can't I just sit here in this output cache tag and say, please go use, you know, provider equals foo. And the answer is for page level caching, that's actually technically not possible for us to pull off. The reason for it is that output caching, remember, underneath the hood, it's actually an HTTP module that runs comparatively early in the HTTP pipeline. And the problem is, on the subsequent request that comes into the page, it's like, well, there's no page. You got to the output cache module, and all we know is you requested this URL, and it had these query string and these form values, but like, where the heck am I supposed to go to find the output cache data? because I can't get to it by looking at the page because there is no page at that point. There's nothing to spin up. There's nothing, I can't like inspect the output cache attribute at that point. So the way we work around that is we've introduced this concept on the HTTP application type. And remember, when you're in global ASAX, you are literally writing a custom derivation of the HTTP application type. And you'll see I have this method here, get output cache provider name, that's an override. So it's a new virtual that we added to HTTP application. And if you're doing page level output caching, you can write whatever logic you want and return back a reference to whatever provider you want. So again, I know it's a little bit awkward, but the general idea is if you want to sit there and do page level output caching with multiple different providers, you can do it. It's just basically you have to write code inside of this method that makes the determination what kind of provider should I actually choose. And so to give you an example of that here, I'm returning the disk cache. I've got the memory cache set up by default. So what we'll do is we'll pull up both pages. So we'll go out and we'll view default ASPX. So this guy's running at 1050-41. And then I'll pull up my advanced page. And that's running at 50 and 49 seconds. Once again, I'll go out and I'll stop the worker process. So the one that's using in-memory caching just lost all of its values. I'll restart the worker process. And now when I refresh advanced.aspx, you see the value stuck because in global ASAX we said please use the disk cache provider. But you'll see if I go to the other page that's using the default in-memory provider, everything just rolled over because, of course, the second I recycled the worker process, everything got ejected out of memory. So keep that in mind if you're thinking about using the output caching feature and you're wondering, how do I select a different provider per page? Like I said, you have to do it programmatically in global ASAX. And then just the last area that I wanted to touch on is, like I said in the deck, we do support output cache extensibility for controls, or AKA fragment caching. And so you'll see here I have, again, a very simple control. I've got my output cache tag. And in this case, note that there actually is an output cache provider attribute that we do support. And the reason why we can support it, of course, for controls is that when you look at the life cycle of when certain things are going on, right, if you actually output cache a control, the page is already running. And the page has already constituted a control hierarchy. And so we can actually look at like a type and say, aha, there's this cached user control, and it's got an output cache attribute. And at that point, we can actually get all the attribute values and realize, oh, I need to go to name provider foo to actually get the fragment cache value for this specific control and this combination of values. So again, I know it's a little bit confusing, but you can always specify a provider declaratively for a control. You can only do it programmatically for a page. So again, let's just go out and see a quick example of that. So I'll shut down the browser, and we'll pull up a page that does have the user control on it. So this is my user control, 1052.49. Once again, I'll go out and I'll stop my worker process, give it a second to come back up again, and when I refresh the page, sure enough, the cached version of that user control sticks because it's actually sitting on disk. So that's pretty much the scope of everything we're doing for output caching. As you can probably guess, just from sort of seeing the two different demos, the output caching work we're quite a bit farther along on inside of the ASP.NET team. We literally, like the build I'm running here, it already has output cache, the feature. It's already been broken apart. We already have the extensibility mechanisms in place, and we've done a fair amount of preliminary testing. So that's why I said earlier, most likely, again, subject to changes, but most likely you'll have that extensibility hook available in the first beta, whereas the object caching, that's going to have to sort of be running out of band initially, and it won't show up until a later beta. And then just one other thing, flipping back to sort of object caching, I should have mentioned it earlier. In terms of this coding style, first off, I just wanted to point out that there is one other overload that you can do when you new up an object cache. And what you can actually do is, if you wanted to, you could put in, I think we have like a memory cache provider somewhere. You can actually new up, for example, an instance of an object caching provider, or you can have an existing reference, and you can go out and initialize a cache facade that will run against that instance of the provider. So you actually have three different ways of sort of interacting with the cache. you've got sort of the default way that just says new me up a cache, but you don't provide anything in the constructor. You've got a way that says new me up a cache facade and give me the name of the provider I want to talk to. And then lastly, you've got new me up a cache facade and give me a reference to the provider that I should talk to. And so if you're wondering, like, okay, why do I have these three different ways of doing it? Again, one of the complaints and valid ones that we got back for ASP.NET about our existing cache is if you're writing unit tests, it's sort of like, well, I want to go unit test some feature, and yeah, it happens to use the cache, but in the scope of the unit test, like, I don't actually really care that there's a cache. I mean, I happen to have a few lines of code that does a get and a set, but that's not actually what I'm unit testing. And basically, it's very, very hard, or in many cases next to impossible, without going through gyrations, to mock up the ASP.NET cache, because it's, again, this black box. It's right there. So the idea of having these coding styles that I'm showing you here for the object cache is that if you wanted to, for example, you could create a mock cache in your unit test framework, go initialize an instance of the cache facade, and you're off to the races. And sort of the important point there is that even though, you know, yeah, I've shown you that there's configuration that can back the object cache feature, you can literally go out and use the cache feature with completely empty config. You can sit there and have no providers and completely programmatically manage newing up your own provider instances and hooking them up to instances of the cache facade and coding against that. And so the whole point there is, from an administrative perspective, you have the config-driven version of the feature, but for the unit testing and for the mock frameworks, you can simply sit there and use the feature completely from code, and you never get tied down having to use configuration. So, okay, let's switch back to the deck, and we'll walk through a few more of the sort of API concepts that we have. Okay, so core versus optional APIs. And this is sort of the sticky part of the new object caching design, and this is specifically about object caching. Output caching is pretty straightforward. You have a base type, you derive from it, you're off to the races. Object caching is a bit of a gnarlier problem because you can run in memory, you can run out of memory, and then when you suddenly start running out of memory, there's a big difference between what you could do with a disk-based cache versus a distributed cache, and there's probably a big difference depending upon whether or not your distributed cache happens to know anything about .NET, or again, using memcached as an example, hey, literally, I mean, it's just a big blob of memory, and maybe it's running on a Linux box. It doesn't know, squat about what it's being given. It's just, here's a key, here's a big byte array, have a nice day. And so the problem that we ran into design-wise, and this is something, again, where when we start code-plexing the object cache API and the work we've done, this is sort of the critical area of feedback we want to get. We had to come up with some way of saying, how the heck do I represent literally like 15 different things you can do with caching that no single instance of a cache engine actually supports all those 15 concepts. And so, again, we don't want to, I don't want to be in the business of being like the United Nations of cache providers, and I also don't want folks who are writing cache providers to somehow feel like they must implement every single last bell and whistle, otherwise they aren't a valid cache provider, because neither one of those approaches are valid. So what we did is we said, okay, we're going to factor the actual low-level cache provider API into 3 separate parts. And the first part is this cache provider base type. And that's sort of a basic level of functionality that we think everybody who would ever write a cache provider is probably going to agree, these are the set of methods that I have to minimally be able to support. And as you would expect, it's effectively a dictionary. It's like, great, I can add an item, I can get an item, I can set it, I can remove it, and I can see whether or not it's there. And about the only sort of new quote-unquote thing is that the API signature for a basic cache provider, it includes the concept of a named cache partition. That doesn't actually mean your cache engine has to implement it. It just means the API at least exposes it as a first-class citizen. And I know some folks are probably going to think, okay, hey, by the way, Microsoft, are you actually going to implement cache partitions on your in-memory provider? And the answer is, in 4.0, unfortunately, no. But it's something that, again, I know everyone who asks me about how the ASP.NET cache works, one of the first things that comes out is, can you partition it? And again, I won't go into all the details, but for technical reasons, due to how managed memory works, it's actually extremely difficult to come up with an accurate partitioning strategy for an in-memory managed cache. So even though named cache partitions are going to be on the public API of the base cache provider, If you happen to use the in-memory implementation from us, it'll just be sort of like, well, great, you asked for named cache partition foo, that's nice, everybody actually lives in the same partition. But okay, enough on the base cache provider type. The idea there is then we have two specializations of a cache provider. We have one that's called the in-memory cache provider, and then one that's called the out-of-process cache provider. And the idea here is that the in-memory cache provider represents what we think logically an in-memory implementation could realistically support. Or to be more precise, it basically has all the functionality that you know from the ASP.NET in-memory cache, because we know all that stuff works and has worked for quite a few years. So if you were to go out and write a cache provider and you wanted to run it in memory, you'd see on the API signature for that in-memory provider that you can implement things like get me how many items are actually sitting in the cache, or go out and use sliding expirations, cache dependencies, and callbacks. And the reason why all of these concepts currently only exist on an implementation of an in-memory cache provider is because distributed caches, it's either next to impossible or it requires a fair amount of engineering to actually implement these concepts. And for example, sliding expirations, comparatively simple to do that when you're in memory and you actually know all the requests that are going on. You can actually keep track of what cache item is being kept alive. If you try to do that in a distributed cache under any kind of load, you're liable to end up with all the network traffic on your cache cluster being all the different cluster machines talking back and forth to each other saying, oh yeah, somebody touched cache item foo, it actually needs to live for another 10 minutes. And then the other cache cluster guy will be like, oh okay, I'm going to go out and make it live for another 10 minutes. Oh, by the way, someone touched me, actually make me live for another 11 minutes. And like you go nuts just sitting there ping-ponging back and forth, constantly maintaining these expiration values. Cache dependencies, from what we've seen to date, again, looking at like memcache, some of the PAG stuff, looking at the velocity stuff, there's not really any concept of what it is to have a cache dependency. And realistically, it is something that could be implemented, but it would have to be like a standalone cache dependency service that's sort of clipped on to the distributed cache. So right now, again, when you see it come out, if you look at the API signature, only the in-memory cache providers can accept a cache dependency. And then lastly, the callbacks. And we have, remember, as of 3.5 SP1, we can now call you either before or after an item gets removed. Well, those, again, are only available on the in-memory cache because I need some kind of a delegate to call back to. And even though, like for output caching, we sort of came up with this restriction, well, if it's static, we can go out and do it. The problem is just more generally for the object cache, you get into this weird situation of I have 15 front-end servers and I have 5 caching servers. So like, who calls who when the item gets removed? Like, should cache cluster server number 3 call web server number 9 to tell it the item got removed? And so again, it's like, well, okay, without a lot of engineering, there's not actually a clean way to have the concept of callbacks in the distributed world. And then if we take a look at the other provider base type, so this is the out-of-process cache provider. This is meant to be the base type that people like Velocity or people like Scale-Out would be able to write a wrapper around their current offerings and expose it as an out-of-process cache provider. And the reason why we have this separated out is a lot of the features here, like the version-based updates and the lock-based updates, those are basically optimistic and pessimistic concurrency strategies for locking an item in the cache and then releasing it. And this is one of these things where, I don't know, we might end up actually bleeding this back onto the in-memory cache. I know I've talked to a few folks this week who've actually explicitly asked and said it would be nice on the in-memory cache, at least on the API, if you supported the ability to say get and lock this item and then be able to release it. But certainly today, like, our in-memory engine doesn't support that concept. Velocity, however, certainly does. If you come from a database world, this is very familiar, right? It's the old trick of how do I make sure one and only one person has this cache item until they're done with it. And so we support that concept explicitly for the out-of-process cache provider. And then, like I was talking about earlier, right now we only have the multiple get operation available on the out-of-proc cache provider because we're like, well, for an in-process provider, who cares? Like, you can get 1 item or 50 items. It's the same thing. And then lastly, this query tag feature, again, only shows up on the out-of-proc provider. And so this is because today we don't have an in-memory implementation that knows how to do this, but some out-of-process providers do know how to sort of store things associated with metadata and then retrieve based upon that metadata. Well, I've got one quick slide on like, okay, what's the plan with velocity integration? They had a few talks here at PDC. In a nutshell, velocity is the distributed cache offering that's being written by the SQL Server team. And the deal is we do work with them. We go over API designs, things like that. They are, however, right now sort of a separate product outside of the framework. So the current tentative plan is what you'll see next year as we go through the betas of the 4.0 framework. Again, most likely what we'll do is we will initially do Codeplex releases of providers for both object caching and for output caching, and also for that matter for session state, so that they're available for people to start working with. And then because of the fact that just shipping schedule-wise, like the 4.0 framework is on one shipping timeline and Velocity is sort of on its own shipping timeline, what we'll end up doing is when 4.0 RTM comes around, we'll rev the providers so that you have, fully compliant ASP.NET and .NET 4.0 implementations that work with Velocity. And then what will happen is, again, on some subsequent release, probably both of the 4.0 framework and of the Velocity product, it'll be some subsequent release where you see those fold back into the respective products as fully supported features. So that's the general plan for how we're going to wire ourselves up to the Velocity product. Okay, so one last quick demo. And this is just coming back to the question of like, okay, I've got these cache providers, and they all have different functionality. Do you have anything that you're building into the framework to at least make it a little bit easier to know what's going on? And we do have this concept right now of something called cache provider capabilities. And so, for example, I'll show it to you right now. We'll go out, once again, new up an instance of the cache, and we'll say, something I'd like to know for my cache instance, for the provider that I'm talking to, I'd like to know what kind of capabilities it supports. So in this case, I'll say, great. If it supports capabilities, I don't know, if it supports versioning of items, I'm going to go out and do something. And in this case, it'll just be a no-op. But the idea behind this kind of coding style is to be able to say, at runtime, at least minimally have some way to sort of programmatically query and see whether or not a given provider supports a specific piece of functionality. And the reason for this is that even though we have the cache provider base type, the in-memory derivation, and the out-of-process derivation, like I said earlier, you don't have to go out and write an out-of-process provider that supports locking, pessimistic or optimistic. It's there on the API so that you don't have to do anything like extension methods or wacky things to introduce the concept, but you're not actually required to implement it. And so, of course, that raises the question of, well, hey, I'm the developer and I'm writing some code and I'm using the cache. How the heck do I know that when I make a call to actually lock an object that it'll actually be supported? And so the idea is that as a developer, you can sort of make these runtime checks and assertions and say, hey, you know something, maybe at the very beginning of my application, I'm going to go through the various providers and I'm going to make sure that they actually support what I think they're supposed to support. So, of course, if I go out and run this, what will end up happening is because, actually what will end up happening is that eventually it'll call in and check what my provider capabilities are. For a second here, let me just, there we go. Okay, I got to put the breakpoint on the right place because, of course, right, my in-memory provider doesn't actually support item versioning. So we'll go through, we'll say, hey, Mr. Provider, what do you actually support? Again, I know you probably can't see it in the back, but if you do, if you hover over the cache provider capabilities, you'll see that my default provider is an in-process provider that supports absolute expirations, and that's all it can do. And so, of course, if I had any logic that actually wanted to use item versioning, it's going to fall right through because I don't actually support that. So again, something to keep in mind that in addition to being able to query the base types of the providers, you're also able to query the provider capabilities programmatically to get a more granular idea of just specifically what does any individual provider support. Okay, so run through a few last concepts here. Just a couple of brief notes on what's involved with migration. So I'll take the simple one first, which is ASP.NET output caching. In terms of migration there, you won't see any changes. Like I've said a few times before, the programmatic APIs don't change, the features don't change. It's just basically something new. You have this extensibility point. If you don't want to use it, nothing happens. All your code continues to work. If you do want to use it, great. You'll have a few constraints, like I said earlier. like static callbacks. But other than that, things pretty much work as expected. Right now, though, for object caching, just sort of looking at where we are, what will most likely happen is that the existing cache object in the system web caching namespace, right now we're on a plan that's going to stay unchanged. And it's just a matter of we have a lot of other work to sort of get the new API built, get it reviewed, sort of probably mutate it 3 or 4 times based upon feedback, et cetera, et cetera. And right now, just tentatively looking at ship schedules and everything, I honestly don't think we're going to get to it in time to be able to sort of have a switch that says, oh, by the way, anyone who calls into the cache object in ASP.NET, please make a left hook and actually go call the new object caching API. Because remember, it's the new object caching API that actually has the extensibility. The old cache object here in ASP.NET, API-wise, it just stays the same as is. So again, feel free to give me your feedback on it, but again, it's sort of more a matter of we're just constrained by it's sort of like a chain of dominoes. I have to get everything else built and the in-memory provider implementation factored out before I can finally get to making this final step. So we already talked about output caching in terms of programmatically what it looks like. You saw for control output caching when you want to opt in, you just use the output cache provider attribute that we introduced on the output cache tag. And then we talked about, and you saw it for page output caching, you have to override this method on HTTP application to be able to actually switch back and forth between different provider implementations. And then I've got listed here at the bottom, these are the specific constraints, and this is actually going to be true for both page and control output caching. Because of the fact that whatever output cache provider is written may actually be running out of proc, we basically limit you to absolute expirations. Right? We don't do sliding expirations because, again, if you're running a distributed system, it's next to impossible to use those. We will support file-based dependencies because, obviously, ASP.NET, right, we're very file-centric, and it's important to know that, oh, this page or this ASCX file change, please evict an item from the cache. So we will support that, even if your output cache provider is pointed at a velocity or a scale out. And then lastly, we do support these callbacks. And these are sort of pretty powerful extensibility mechanisms, but the slight restriction is you need to make sure that there's static methods so that we can actually reconstitute the callbacks when we come back up again. I'm not going to walk through this slide, but basically, at home or at work, you can briefly look over it. It gives you a general idea of, hey, this concept in system.web.caching, where does it show up in the new object API? And the main thing is, any concept that you've been using today in the ASP.NET Object Cache, there is sort of a concomitant location for that in the new Object OM. It just might have moved around a little bit. So, okay, to close things out, hopefully you get the idea that sort of the top level point, and the most important thing we're trying to do here is make sure that both object caching and output caching are pluggable. And that's not just for, we in Microsoft to write stuff, it's for you guys to go ahead and play around with, to buy or to purchase or try out, whether it's open source or not, different kinds of caching implementations. So the idea is everyone can basically be a first-class citizen and play both inside of object and output caching. And then the other nice thing, like I said all the way back at the beginning of the talk, the nice side effect of the object caching work, everything moves into a different namespace and into a different assembly, and as a result, we can finally make it available on both the client and the full framework SKUs. And it means that for all of you as developers, hopefully you don't have architects running after you anymore saying, why the heck do I have to reference System Web DLL in the middle of my fat client project? So, okay, that's the talk. Again, thanks for dropping by. Since we've got a few minutes here, feel free to step up to any of the mics and ping me with questions.
Yeah. I had a question. Had you considered at all creating a conditional get? In other words, like an e-tagged or something like that. If we have a really large item, especially if it's on an external dependency, if the client's already got the copy, we'd prefer not to have to ship that item again, if possible.
Yeah, so the deal there is up at the cache facade level, the level of that cache object. Of course, it's not going to have any clue when you call get. It just says, oh, okay, you want to get an item with a key value. What I would say is the actual implementation of the underlying provider, for it to be able to do the conditional get, it would actually have to have like a little look-aside cache that it keeps in memory that sort of front ends what's on disk or over in the distributed cache cluster. Because otherwise, basically, how do you know that you have the item so you don't have to make the round trip out of proc? So I guess my deal is, or the answer is yes, you can do that, but that sort of sounds like the cache provider implementation would know how to do that just natively as part of its get method. Does that make sense?
I think it makes sense. However, the typical example would be when I request an item, I give a hash of the item I'm holding at this time. So I'd have to pass the hash through, right?
Yeah, so right now, the only concept we have for looking up an item is off of, like, again, it has to be a stringized key value. But again, this is the thing where we specifically made it a string just to keep it simple. But if your provider, your caching engine, knows how, for example, to look up via hash, it's like, great, go pass that in. And again, it's sort of up to the cache provider to do that. Sure.
Okay, thanks.
Okay. Yeah, and so the question was the version a solution to it? The answer to that is no, because versioning is about, given this item, what's its current like timestamp or version number inside of the distributed cache, which is a little bit different than saying, given an item, how the heck do I actually get back to it, which is the hash.
Let me make sure. Excuse me, I'm sorry. Sure. Actually, that comes very close to the question I was asking. Maybe I wasn't clear. It's not whether or not the item is there. It's whether or not the item that the client already has is the exact copy.
Okay, so to that question, the answer is yes. That concept is supported in the APIs. And also, just a little segue note. So this is one of the things where we have to sort of do a couple of go-arounds, and again, hopefully with all of you in the community with feedback on how much we explicitly expose in the cache facade versus how much you have to sort of know, oh, okay, I need to new up a cache item and set it explicitly with X, Y, and Z, and then when I call get, it'll do it. So to your question, right now, the way it would work is you would new up a cache item, you'd set the key value, and you'd set basically the item version, you'd call get. And if the cache provider supports what you're saying, which is basically a version get, it would look at it and it would say, oh, you know something, your version matches what I have in the cache for this key, and I return null. But if it doesn't match, I'll actually return you the real thing. And so, and I've sort of heard this again from a few other folks. I'm beginning to think sort of more complex concepts like this, we could also explicitly put on the facade like get if non-matching version, and then that way you don't have to know, oh, new up this thing, set that property. It's a lot more explicit. So I'll take that as a vote of yes, you would like that.
Yeah.
Okay.
Are you planning to persist updates in your in-memory cache to disk?
So the in-memory cache engine, literally, it's going to be the ASP.NET engine right now, just lifted up, factored out, and dropped down into another assembly. So in 4.0, the answer would be no. However, to your question, what I'm hoping is that we have this thing should be so pluggable left, right, up, and down that you should be able to take our in-memory cache engine, which will actually be public, and it'll be a public provider, it'll be unsealed, you can override it, you can aggregate it, and you should be able to literally write additional code that wraps it that says you're going to add a persistent backing store that works in tandem with it.
Okay, thank you.
Yep.
Hi. You talked about a lot of limitations of out-of-process cache, but all these limitations seems to be tied with distributed cache. Is there some solution of out-of-process cache that is not distributed cache, like ASP NET State Server, SERSE?
Yeah, so, I mean, yeah, and it's a good question because right now, the way we modeled things on the out-of-process provider, on the out-of-process cache provider, implicitly we were thinking, well, that's probably really a distributed cache. And yet you are right that you could go out and sort of introduce concepts in a disk-backed provider where you can support more things like cache dependencies that are, like I said, very, very difficult to pull off in a distributed cache. And honestly, right now, we had to sort of make a dividing line that said this kind of functionality wouldn't go on an out-of-process provider, but it would go on an in-memory provider. So I guess my question back to you would be, what would happen if instead of calling the two types in-memory provider and out-of-process provider, instead we made it something just more generic like, you know, I don't know, advanced provider and somewhat simpler provider. So we didn't actually specifically say anything about being in-proc or out-of-proc. Would that like clean up the confusion?
More confusing. It seems for me that there is three types of cache: in-memory cache, out-of-process cache, and a distributed cache that is derived from the out-of-process cache.
Okay.
It should be better.
Okay, so I see what you're saying. Well, I'll tell you what. I'll take that down. I'll take back that feedback, and that's something that's something we can think about, is sort of adding in one additional layer to sort of make it distinct between, maybe a near cache, like a disk cache, can do more than just a true blue distributed cache. That's reasonable.
Okay. Just a detail. When you change the cache provider through the application class,
Yes.
but don't change the cache provider through the output cache tag at user controls. The user controls will use the change in application class or the default cache provider in web config.
Okay, so for the, let me switch back to the code here for a sec. So for the output caching, so this is the user control. This declarative option. This is just an additional. This is an additional feature when you're using output caching with controls. There is actually, right, remember, programmatically, there's actually like a static partial caching control, and there's a partial caching attribute. So I didn't show it here, but you can actually programmatically also make this choice.
If you don't put this, so it will use the application cache in application class or the full?
It will use the default provider that's in configuration, which in 4.0 will be the in-memory cache.
Oh, okay. So for a website, we need to define the default provider in two places, the web config and the application class.
No. So if you're comfortable with running things in memory, you won't actually have to do anything, because by default, ASP.NET 4.0 out of the box will already say the output cache feature uses the in-memory provider by default. You won't have to write code anywhere. You don't have to set anything. That's the default. So when you move from 2.0 to 4.0, nothing changes.
But if I'm changing, I need to replace in these two places.
So if you want to change everything, like your default for everything, you just come in one place and you change this. And basically, so right now this says memcache. If I were to come back here to this user control and get rid of that, this user control will now automatically use the memory cache that's set in web config.
And the pages will use that?
Yes, same exact, yes.
Okay, thank you.
Yep.
Thank you.
No problem. Sure.
For the disk cache, what control will there be over where on disk will actually use that, and like sizes and things like that?
Yeah, so one of the reasons why I said earlier that for the disk output cache, we're not going to ship it in 4.0 is precisely because these kinds of questions, like we know that we're not going to get all the configurable knobs right in time for 4.0 RTM. So I can tell you up front, like right now the way this thing works is, and this is just again sort of the preliminary version, it's hard-coded to go into the temporary ASP.NET Files folder, into the specific subfolder for the running application. However, just like today, it's not obvious, but you can do it for page compilation. You can actually change the temp files directory for your application. What we will do, and most likely what will just end up happening is, somewhere on the add element, just like we do with like membership, there'll be a bunch of other things that say like, disk cache, location equals, and you can put in C:\, whack, whack, whack. And as long as the running application can get to it, we'll go write stuff there. In terms of like quotas and stuff, I honestly don't know that we would even implement that when in a later version of the provider. The only reason for that is typically if we give you the ability to write to a disk location that's somewhere else, usually I think Windows does a much better job. You can just go to that location and configure a quota for a user account and say, yeah, don't exceed whatever 500 meg. And that will probably be our approach for solving that.
Thanks.
Yep. Sure.
So with the output cache declaration that you have on the page, not allowing the attribute to specify the provider that it uses. So I understand that the HTTP runtime has no way of knowing without instantiating the page what the settings should be. I guess I was curious, could you not use like a static dictionary and actually have it track, map the page to the provider that the page used when it put the input information into cache, and then only use the global ASCX thing for extreme cases?
Yeah, so the problem is this. What happens if the item is already stored in the disk output cache, or for that matter in a distributed cache, and your worker process goes down? When I come back up again, on the very first incoming request for this page, if it's already in the output cache, I should serve it from there. So how do I actually know where to go to get the item out of the correct output cache? Your dictionary doesn't exist because the process cycled. So I've got nothing in memory. That right there is like the crux of the problem. From a true blue cold start scenario in a web farm where somebody else in the web farm got the item into the cache because they got the hit, so they put the item in the cache, this other web server has no clue that that happened. And so the point is, it has to know ahead of time which provider do I go to make the check to see whether or not the data is already in the cache. And so anything we could come up with would like have a little look-aside list, like that all works in a warm start situation where I've already seen the request, but the second I've been recycled, like I don't have any of that. And so that's the technical constraint.
Cool, thanks.
Yep.
Yeah, just a quick follow-up on his question.
Sure.
And I may be off here, but couldn't it be a possibility to use the location tag in your web config to specify on a location basis what output cache provider to use?
So, let me put it this way. You could use the location tag for this section, but the problem is this section is only supported down to the level of the application. So you know that location tags, you're right, like you can put in whatever location you want all the way down to a subdirectory, but about 95% of the time, chances are the thing you're trying to configure has no clue of what it means to change its behavior based upon like page or different virtual directory. And so let me put it this way. Technically what you're asking for, it's certainly not impossible, but we were planning right now to just sort of slipstream off the existing output cache section, which sort of means that at least whatever shows up in config, we only know, like, we know it to the app level. We did have, however, and this might actually be an interesting idea. So if you've played around with a feature called URL routing, they have a concept where, like, programmatically in global ASAX, you basically register ahead of time, oh, okay, given these regex, well, sort of string matches, this is where you go to actually execute it. Would it be reasonable to sort of turn the problem around a little bit and say, if we gave you a way programmatically at app startup to basically tell us, for these pages, please use this provider?
Yeah, that might work.
Okay, yeah. So that's interesting. Again, no guarantees, but I'll take that back there because that might, if nothing else, it would be trivial for us, I think, to put the hook in to allow that extensibility. And then that way it's like, okay, sometime in the future we could make it an XML-based file, you know, et cetera, et cetera. But
yeah. Okay, great, thanks.
All right. All right, well, looks like I'm getting kicked out, folks. So, again, thanks for dropping by. And like I said, sort of keep an eye on CodePlex probably early next year. Who knows? If the stars are aligned, maybe it'll be a little bit faster. But we'll certainly get info out here on everything I've talked about so you can sort of get previews of it. Thanks again.